Page 478, we're going to be reviewing lessons 8.1 through 8.4. So lesson 8.1 was on scale drawings. So scale drawings, we've made things either bigger or smaller. Blueprints, for example, maps, things like that. And so we have this certain scale. So on this problem, the first one, they want us to use the scale drawing. And so they're asking, what is the actual area of the meeting room in square yards? Okay, so you can see the scale for the meeting room. Okay, what the dimensions are on our scale drawing, and then they've provided the scale so we can figure out what our actual dimensions are, and then we could figure out what our actual area is. So the first thing is we're going to want to figure out what our actual lengths are, actual dimensions. You can use this scale if you want. You can write it out like this. If you can just figure out what you need to do, that's fine also. But basically for this one, we'd multiply by 1.5, and that would be 4.5 yards. And then for the other one, it's 4 inches. It's just going to be 4 times as much. So that would be 12 yards. And then we know an area of a rectangle is length times width. So if we just do 12 times 4.5 would be 54 square yards. So if we look at number 2, John decides to make a new scale drawing of the meeting room. He wants the length of the room of the new drawing to be 8 inches. What is the new scale for the drawing? Okay, so he's going to change it where the length is 8 inches. So different ways we could do this, but basically for our scale here, we have 8 inches that we want to be the length. The actual length we figured out on the first problem, the actual length was 12 yards. So we want 8 inches to be equal to 12 yards. For a scale, it's nice if we know what 1 inch is equal to. So if 8 inches equals 12 yards, if we divide both of these by 8, then that would tell us 1 inch equals 1.5 yards. You could try to think about it, reason it out that, you know, it was 4 inches, now it's 8 inches. You know, you can try to reason that in your head, but then you got to think about, you know, am I doubling or am I dividing by 2? It might be a little bit more thought process. It might be a little bit easier doing it this way, just going with the 8 inches that we know we want and knowing that it was actually 12 yards and then just reducing that down. Section 2 is on drawing geometric figures. So they gave us some information and then we had to draw whatever it was they asked us to. So number 1, we want a quadrilateral with 2 pairs of parallel sides. And one measures 5 centimeters and one measures 3 centimeters. And one angle measures 45 degrees. So that's going to limit us down to, when we draw this out, should be a parallelogram looking something like this. And then if we look at number 2, what quadrilaterals can you draw that have 2 angles measuring 115 degrees and 2 angles measuring 65 degrees? So some different options we would have for this. Possibly we could have a parallelogram We could have a trapezoid. A variation of the parallelogram, we could have a rhombus. Lesson 8.3 is on drawing triangles with given conditions. So one of the things we looked at here was whether we had unique triangles or whether we could draw more than one triangle with the conditions they give us. So number one, if we have side lengths of 4 centimeters and 2 centimeters and an included angle of 50 degrees. An included angle means the angle between those sides is 50 degrees. So if you can imagine just kind of sketching this out, let's say this is 4 centimeters. We're going to draw a 2 centimeter side, but the angle between those sides has to be 50 degrees. So if that's maybe something like this, 50 degrees, that's 2 centimeters. And then the question is whether we can draw more than one triangle with this information. Well, we're kind of stuck because we have endpoints for both of these sides. So the only way we can complete our triangle would be by connecting the two. So for this one, the answer would be no. After we draw that angle, then there's only one way to draw the third side of the triangle. And then if we look at number 2, if we have a triangle with angle measures 25 degrees, 65 degrees, and 90 degrees, is it impossible to draw a triangle, possible to draw only one triangle, or possible to draw more than one triangle? So first, if you think of these angle measures, we have 25, 65, and 90. The one thing we want to do is we want to consider whether we have 180 degrees total. So if you add these together, that does add up to 180 degrees. And so potentially we could draw a triangle with it. The only question now is, can we only draw one triangle, or do we have more than one option? And if you think about it, they've given us 3 angle measures, but they haven't said anything about the side lengths. So with 3 different angle measures, but no side lengths, so if you can just imagine, let's say we have a 25-degree angle, a 90-degree angle, and a 65-degree angle. So maybe it looks something like this. If you think about that, we could make this triangle either bigger or smaller, and it would still have those same angle measures. So for this one, this is not going to be a unique triangle, and so we could draw more than one triangle with these angle measures. And like I said, it could be either, enlarged or scaled down to make it still a similar triangle, but a different triangle. Lesson 8.4 was on solving problems using angle relationships. So first of all, over to the side, some different things we talked about. Adjacent angles have a common side, so they share a ray with each other, you could say, adjacent angles. Supplementary angles have a sum of 180 degrees. They add up to 180 degrees. Complementary angles add up to 90 degrees. And then if 2 lines intersect, and basically you just continue those lines further, then those would form vertical angles, and vertical angles are equal or congruent to each other. So you can see in the example in your book, they've mentioned a couple of sets of vertical angles. If we come over to these problems, number 1, they want us to name a pair of complementary angles. So complementary angles add up to 90 degrees. So you can see the 90-degree angle symbol here in your book. So we just need the two angles that would form that. So that would be angle QZX and angle XZY. You can see those two angles add up to 90 degrees, so those would be complementary. And then if you look at number 2, if the measure of angle XZY is 55 degrees, which other angle has a measure of 55 degrees? That would be angle SZR. So if you look at XZY, take this off of here, okay? So XZY is here, then SZR or RZS would be a vertical angle, because if you think about it, if you just continue those lines out further, that forms those vertical angles. Okay, so if this is 55 degrees, then this also would be 55 degrees. And then if you look at number 3, if we use the information from problem 2, find the value of n. So if we know those 55-degree angles, we need to figure out what n is equal to. You might notice that the two angles at the bottom form this straight line, so that would be 180 degrees total. So we could either write an equation, or we could just kind of think about what's happening here. Straight line's 180 degrees, so 180 minus the 55 degrees we already have would be 125 degrees. So that's telling us that other angle is 125 degrees. And you can see that it's equal to 3n plus 5. So from that point, we could say 3n plus 5 is equal to 125. And then we could subtract 5. So 3n equals 120. And then divide by 3. And figure out that n equals 40. We could substitute that back in. 3 times 40 is 120. Plus 5 is 125. Plus 55 is 180. So that works. You could also start with an equation of 55 plus 3n plus 5 equals 180. And if you do that, you do have the option here that you could combine like terms. 55 plus 5 would be 60. And then subtract 60. And you would get 3n equals 120. And then notice we'd be at the same spot we were when we solved it the other way. So different ways of working it out, but we should get n equals 40, whichever way we do that. One other thing besides that, if you remember, we did a couple of worksheets about vertical angles and supplementary angles. So the vertical angles, we set those equal to each other. In this case, if you look at this problem, finding the value of x, these are supplementary angles. So this one we have variables in both parts. So we really would probably need to set up an equation. And so these two things added together would equal 180 degrees because they're supplementary. And then what we can do is look for like terms that are on the same side of the equation. So 1x plus 2x is 3x. And then we have some other like terms here. So 34 plus 2 is 36. And then to get the x term by itself, they're adding, so we can subtract 36. And then they're multiplying, so we can divide by 3. We can could just divide that off to the side here. So from that, x equals 48. At that point, they could have also said, like, what's each angle equal to. They didn't do that, but it still might be a good thing to look at. X plus 34, so 48 plus 34 would be 82 degrees. And then the other angle, we had 2x plus 2. So 2 times 48 would be 96, plus 2 is 98. The value of doing that is once we get those, we could add those together and we could make sure that those add up to 180 degrees like we said they would. So this gives you an idea of what we're looking at with lessons 8.1 through 8.4. Have a good day.